Hello everybody, my name is Magnuri and this is the recording of the talk I did last week at Dev Barcelona 2025, where I gave a good overview of Model Context Protocol and how to implement your own servers. My name is Magnuri. I work as a software engineer at Red Hat, where for the last 5 years or so, I've been working on developing tools for Java developers who implement or have to deal with Kubernetes on their day-to-day life. However, for the last couple of months, I've also been working on several tools for AI, and more specifically, I've been working very hard on the Kubernetes MCP server and the Podman MCP server. And today's talk is mostly about sharing my experience while developing these servers. You can find me on social media, on many social networks, LinkedIn, Twitter X, Blue Sky, wherever. So if you have any questions, please reach out. Also, this will be published on YouTube. So if you have any questions, please set them in the comment section and I will do as possible to reply them. So this is the agenda for today's talk. Usually when people talk about MCP, they probably start with a diagram about the general architecture, the overview. However, I think that it's much better to start by understanding what kind of problems Model Context Protocol is actually solving, and hence understand why it's become so popular. So I will start by this, and then I will give this overview of the components too. And finally, I'll try to share some insights on how to develop your Model Context Protocol servers. It won't be that much into how to implement them code-wise, but more about the good practices, how to avoid certain challenges, and so on. So yeah, in order to understand this slide should remind you maybe of the interface of Claude or any other AI assistant that you might have used. And basically here I'm going to set several prompts and we'll see how these assistants tend to reply. So first one, I'll be in Barcelona next week. What's the best time to visit Sagrada Familia? So I guess that many of you typically use this kind of assistance to maybe plan your trips or things like that. And this is something that I do too. So this week I'm at Barcelona and I want to plan a visit to Sagrada Familia. I will send this prompt, and typically this is the kind of response that I might get, right? So early in the morning or late in the afternoons during weekdays, and avoid weekends and holidays if possible. So probably it's giving this kind of advice to avoid crowds and to have a more pleasant experience. However, let's say that the newspaper that day had these headlines, so deadly thunderstorms imminent for Barcelona, authorities advise people to remain indoors. So obviously the model didn't have the information about what was happening today, because it probably had a knowledge cutoff a couple of months ago. So it's impossible that it could give us this advice. However, now let's say that we've started the Model Context Protocol or added this feature. So we see this icon here. Let's repeat the same prompt. And now, basically, the assistant and the model have access to this tool, which is called Weather Forecast. So it can make a request to this tool. And with the additional context, it can reply, given the thunderstorms affecting Barcelona on Monday and Tuesday, the best time to visit Sagrada Familia is during the last part of the week, specifically on Thursday or Friday, best early morning or late afternoon. So it's a much more accurate and much more useful response for us. Similarly, let's say that we go back to this original prompt and we're asking what was the best time to go to the Sagrada Familia. The typical follow-up question I would ask for a real assistant would be, hey, can you order the tickets for me? Probably you've tried this. I don't know if you've tried this on ChatGPT, but this is the kind of response that you will get. I can't directly order tickets for you, but I can guide you to the right place. Official website, sagradafamilia.org. You'll need to select your day, time slot, and ticket type, Basilica only, Basilica plus towers. This site accepts major credit cards and shows real-time availability. So, I mean, the model had all the information. It even knew about the kind of tickets that it could buy. However, it relied on us, the human, to perform the grunt work, right? So you have this kind of assistant that it's not really assistant, it's giving you orders. That doesn't make much sense, right? Let's say that now we have enabled the model context protocol, and we do the same follow-up prompt. Can you order the tickets for me? So maybe the LLM, the assistant, has now this tickets order function, and it can reply, I successfully booked your ticket for Sagrada Familia on Thursdays at 9 a.m. You'll receive a confirmation email shortly. So yeah, much more useful. It actually did what an assistant should do, perform the task for us, right? And yeah, I think you may be wondering, hey Mark, but I've seen that Anthropic, Cloud, or ChatGPT, or many of these tools actually are scraping the web or have built-in functionality that resemble these things that you are showing. And I'd say, yeah. I mean, many of these tools have been implemented by them. However, they are usually for mainstream functionality. Let's say that now instead what I want is this kind of prompt. I need a Postgres database. Can you deploy one for me in your Kubernetes cluster? I don't think that Anthropic or OpenAI or whatever company will build such a domain-specific functionality to be consumed by the general public. So if we repeat this kind of prompt, we'll receive a similar answer as before. I'm unable to directly deploy infrastructure access to your Kubernetes cluster myself. However, I can guide you step by step, generate the necessary Kubernetes YAML manifests, and so on. So yeah, just like before, the LLM actually has the knowledge to do this, but it doesn't have the capability because it cannot interact with external systems. If we provide this MCP server, maybe the Kubernetes MCP server, we can actually provide this function, pod create, or even port forward, and the LLM will reply, I've created a Postgres pod in your Kubernetes cluster and forwarded the port to your local machine. You can now connect to it using the following database connection. So it did the work for us, and it even provided us the connection settings for the database. So let's just recap what kind of functionality MCP is providing. So basically, real-time context. The MCP adds this functionality to the LLM that it can actually retrieve data, real-time data, and real-time data from the external world. So the responses become more accurate and more up-to-date, and also more useful for the users. The assistants become real assistants. So since MCP provides this means for the LLM to interact with the real world, it can actually perform the tasks for us, the humans. Instead of relying on us to perform the tasks, it can perform them for us. Yeah, some of these things are not new, but the MCP is actually providing the standard. And finally, with MCP, you can provide these specialized tools. So we saw the Kubernetes one, but maybe you have some functionality very specific to your company, or very domain specific, or something that's internal to you and you don't want to share with the general public, but use internally. So MCP actually provides these features. So yeah, now let's get this overview of what MCP is. Yeah, we'll start with this general architecture. Probably you've seen this diagram already, and these are the main components of model context protocol. We distinguish those that run on a remote network and those that run locally in your computer. So the first and most important one is the MCP host. Usually this would be Cloud Desktop or your IDE or whatever assistant interface you're actually using. The MCP host will have several MCP clients that will be run by it. And these clients will connect to different MCP servers. So MCP is a client-server protocol, which can use several transports. We will go into the transports later on. But let's say that you have this MCP server one that it's running in your local system and is connecting to an external system such as Slack in this case through its web APIs. Maybe you also have another MCP server, let's call this MCP server 2, that's also running in your computer. And in this case, it's used to manage local resources, maybe files or a database or whatever. And finally, you have maybe MCP server 3. It can be the GitHub MCP server, which is actually exposed by GitHub itself, and you can connect to it with the MCP client performing a remote HTTP connection. So now we've seen the different components, but let's see let's see the most important part, which is how they interact between them. So we had before this interaction from a user, in this case me, which I was asking the assistant, what's the best time to visit Sagrada Familia? So I type this in my interface and send this to the assistant, which in this case, the MCP host, which will be acting as the main orchestrator. So the assistant gets this initial user prompt and the tool information, the tools that it has available, and sends it to the LLM. The LLM analyzes this, and it might opt to choose to run a tool, because the tool might be significant to improve to provide the response to this initial prompt. So in this case, the assistant will send a tool invocation to the MCP client, which in turn will send this tool call to the MCP server, in this case the weather forecast for Barcelona. Let's say that this MCP server is the weather MCP server, a hypothetical MCP server that connects to a remote weather service such as AccuWeather or something similar. So this performs an HTTP request, get the weather for Barcelona in Spain, and let's say that this remote service returns the information for the weather, maybe in JSON, CSV, or whatever. It returns it to the MCP server, which returns it to the MCP client, which in turn makes it available for the agent or the assistant. The agent has now the original user prompt plus the tool call response. So with this information, it sends it back to the LLM, which now has the full context. And it's now able to provide this much more accurate and much more helpful response. So visit on Thursday when the weather improves. And yeah, this is, I want to stress on the point that MCP is not providing anything new. However, it's providing this standard, this protocol. So before there was MCP, Cloud Desktop, ChatGPT, or whoever had to implement the relationship with each remote service, so GitHub or file system or Slack or whatever, anything, maybe to scrape the web, the weather service, anything that wanted to be implemented or we provided to the LLM had to be custom created for that assistant. So this implies much more costs, right? So each one had to do that same functionality. After MCP, what we have is this protocol that standardizes this communication. So the assistants only need to implement the MCP part, the MCP layer, so it can connect to one or more MCP servers. And then each server only needs to implement the part for connecting to the remote service or the local resources such as the file system and so on. So there is all of this reusability and even interoperability. The MCP provides this layer that unifies the different APIs. And yeah, to better understand the MCP ecosystem, it's also worthy seeing or checking the timeline. So it's not even been a year since Anthropic announced MCP. It released the initial version of the protocol and also some reference implementation. So that was November 2024. Just a month later, there were many community integrations. So there were already the GitHub and the YouTube integrations made by the community. But in 3 months, so in February, there were already more than 3,000 MCP servers. So there was an explosion. Everyone was implementing their own MCP server. In March, there were some deficiencies that were found, especially on the security and authorization, authentication. So there was a new version of the protocol released. In April, you could see like most of the CEOs in the major companies embracing MCP. So Google was saying to MCP or not to MCP and several others. On May, Windows 11, this is a curiosity, announced native MCP support for Windows. And finally, just a couple of weeks ago, there was yet another release of the protocol. So yeah, these dates are important, obviously, but what I want you to understand here is how quickly this ecosystem is evolving. I've never seen anything like this before, and if you disconnect maybe for 1 week, then you're missing a lot of stuff because things get released every week. So it's something that is progressing really, really fast. So yeah, now we have a good picture of MCP, I hope. Let's now see how to implement your MCP server. So we'll start checking what features can your MCP servers provide, how you should describe these the features, tools, or your functions, and so on. What kind of programming language you should use and how to select it, the different deployment strategies for your MCP server and how that might affect the functionality that you can provide, the ways to distribute the MCP server, and also how the model size might also be really important in order to implement functions in one way or the other. So the first thing, the kind of features that your MCP server can provide. So these are the main ones. Resources. Resources follow this uniform resource identifier pattern. So you have some sort of URI where you can expose certain things. For example, in this case, we would have this DevBcn 2025 session sort of endpoint where, and whenever the LLM opted to read this resource, we could return a JSON array with the information of the sessions for DevBcn. Similarly for speakers, or maybe for using a resource, a URI template for a given speaker information. Same as we can return JSON information, we could also return Markdown. So in this case, we could have this other URI with documentation, MCP, concepts, architecture, and return a Markdown document. It doesn't matter what kind of information does your resource returns, as long as your LLM is capable of understanding it. The other main feature is prompts. So prompts could be understood as some sort of shortcuts you could offer to your users or the users of your MCP server to reuse certain prompts. So we are in the age of prompt engineering, I guess. Many of you will have such great, well-crafted prompts that can achieve certain functionality from an LLM. And the whole goal of this is to actually share these prompts that that work well with your MCP server with your users. So maybe in this case you would have this prompt speaker that would have this argument name. So you could replace this with /speaker and in my name, and this would be replaced with show me the biography of the DevBcn 2025 speaker named Mark Nuri, blah 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 blah. So yeah, this is a stupid example. Usually you would have a very, very long prompt, and that would be actually the kind of good use case for this functionality. And finally, and probably the most important one, tools. We already seen a little bit how this works. So your MCP server can expose function or tools that the LLM can then call. So yeah, whenever your MCP server exposes some tools, the client and eventually the LLM is going to receive this JSON with the tool definition. The JSON contains some metadata for the tool, the name, description, the input schema, and then also some annotations. The tool descriptions are really important, and they should be fine-tuned both for the users, but most importantly for the LLMs. I can tell you that depending on the underlying model, having the description in one way or another, like maybe moving a word around and so on, can change drastically the behavior of your MCP server. So my recommendation is to experiment with several models to see how these tool descriptions are then maybe used or not, and also with different prompts. So you should be aware of the kind of user interactions your users will have with your MCP server and the assistant, and try those different prompts to see if the LLM is actually picking up the tool when it should. In addition to these descriptions and this metadata, we also have the annotations. And the annotations are particularly useful mostly right now for the assistant. Probably they are forwarded to the LLM too, but right now for end users and the assistant to improve the user experience are the most useful. So these are the kind of annotations you have. The title is the human readable version of the tool name or even the tool description. So this is what will be displayed to the user in the assistant. The read-only hint basically says that this tool won't perform, if true, it won't perform any changes. Destructive hint, if true, the tool might perform some deletions or destructive operations. Idempotent, if the tool can be called multiple times safely, or open world hint if your tool is actually interacting with the external world or not. So maybe, for example, your assistant, if it wants to improve the UX, if a tool is annotated with a destructive hint, and the LLM invokes this tool, maybe it can provide a confirmation or add a confirmation for the human to approve the usage of their tool, for example. Yeah, so let's now focus on the programming language, right? So you want to implement your MCP servers, you will need to use a programming language. How to choose this language? So there are libraries for all mainstream languages. Whatever programming language you're using, there's probably either an official MCP library or a community provided one. So that shouldn't be a factor or the most important factor. So if your team works with Rust, why not implement it in Rust or Ruby or whatever? However, maybe you want to choose based on the language ecosystem. So this is a good example for the Kubernetes MCP server. It was initially implemented in Java. However, most of the Kubernetes tooling is based around Go. So I opted to port it to Go in order to provide more functionality. So this is something that might be also applicable for your MCP servers. If maybe you are implementing an MCP server for an internal product that's based on Ruby, why not use Ruby? Another factor to consider is how you're going to distribute the MCP server and how is your MCP server going to be executed. So if your users have a valid execution environment for your MCP server, they are JavaScript users, maybe they have npx or Python or so on. So that's another thing that you need to consider. We will check this better later. Also, in order to add functionality to the MCP server, one of the other important things is how your MCP server is going to be deployed. So there are several deployment strategies. If you recall the diagram we saw about the architecture of MCP, we had things that were running locally and things that were running remotely. So let's say that you have this local deployment strategy where your MCP server is running along with your MCP host, the AI assistant, and the MCP client. So in this case, the MCP client starts the MCP server as the MCP client or the AI assistant starts the MCP server as a child process and uses standard I/O for communication. So in this case, the security for the transport is not a problem because it's internal communication. There's nothing exposed. The MCP server is also able to access your local resources. So since your MCP server is running locally, it can access your local files, maybe a local database, or things like that. However, your MCP server is able to access local resources, and you need to be very careful because you might be subject to supply chain attacks, and eventually your MCP server might be running malicious code that you don't want. I see many times on videos or tutorials on the internet, hey, I've seen this MCP server, it's super useful, use it. My recommendation is to vet everything and to check maybe the source code, trust things that are open and check the source code and see everything for yourself. Otherwise, you might run into problems. And finally, the main counterpart is that you won't be able to access this MCP server usually from remote assistance. So let's say that ChatGPT now supports MCP. Your MCP server that is controlling your local files won't be accessible to the remote ChatGPT interface. The other deployment strategy is remote. In this case, your MCP server is running in a remote network, maybe the internet, and your MCP client connects to this MCP server through servers and events or the streamable HTTP based communication. Servers and events were deprecated in the latest protocol release, so you shouldn't really worry about this. Implement the server using the streamable HTTP. Yeah, here this is exposed on the internet, so you should be really careful and provide some sort of security management. So MCP has OAuth in the protocol, so your MCP server should be secured using OAuth too. you won't be able to access local resources. The MCP server is running online, so it won't be able to check your local files or your local database or whatever. However, since it's running remotely, it will be accessible for remote assistants like ChatGPT or whatever. Distribution. Okay, so you've implemented your MCP server, and now you need to make it available for your users, right? So in order for them to deploy it. So we distinguished two kinds of deployments. Remote, we just saw it. So basically this is really simple. You just need to expose the MCP server on a public endpoint, or maybe on your internal network endpoint, and of course provide this authorization. So maybe this is like the configuration for the GitHub MCP server, which is exposed directly by GitHub. And here you would provide your bearer token, that in this case is your personal access token for GitHub. So really, really simple, probably the most simple of all. For local distribution, in case you implemented your MCP server using Python, then you can leverage the Python package index. You can publish your MCP server there and then run it using UBX Kubernetes MCP server, and straight ahead that would start download the MCP server and start it in your local environment. So here it would be like also the settings for your IDE or your assistant. The similar story is for JavaScript or TypeScript. You could deploy this or publish this MCP server in the Node Package Manager, and then use npx to start it, download it, and start it automatically for you. So this would be the command to start the Kubernetes MCP server using npx. For the rest, well, you could use you could package it as a container image, as a Docker image, and then publish it to a container registry such as Docker Hub, the GitHub Container Registry, Quake.io, etc. Then you would run it locally using either Docker or Podman, Docker Run, and whatever. Here it's more complicated because if you want to have access to local resources, then you would probably need to mount a local directory or expose environment variables and so on, but still it's possible. And if you've been paying attention, I showed the npx and the UBX examples using the Kubernetes MCP server, but you might be saying, hey, but the Kubernetes MCP server is Go. How are you exposing this to the PyPy package repository or the NPM? Well, what I'm doing here is a little bit of a hack, and maybe you might want to check it out and check the repository, because you might want to reuse this strategy. So what I do here is cross-compile the MCP server to different platforms and architectures, and then wrap these binaries in npm and Python packages. So I would have maybe a JavaScript file or a Python file that actually, when it's run by the npx or UBX, it downloads that binary and then starts it as a child process. Then I basically publish this JavaScript and publish and Python to the npm or PyPy package repositories and make it available for users. Okay, so now let's consider the model size and how this affects the kind of tools on the way you implement the tools or function for your model context protocol server. So typically we categorize model sizes into different, like we have the small language models, which typically have 10 billion parameters or less, or the larger language models such as Claude Sonnet or any of the models provided by OpenAI or the major players. So considering this model size and maybe a user interaction like run a pod with the container image Nginx and expose port 80, depending on what kind of size the model has, we could consider two different kind of personas. Usually, when I do this with a live audience, I would try to pick someone from the audience who is a Kubernetes expert and will act as the large language model, so someone who is knowledgeable in Kubernetes and can perform tasks using kubectl or whatever. And then I would pick another person from the audience, maybe a developer, who is an English speaker and basically is able to call a function within their code, right? So this person would act as the small language model. So if we go back to this prompt, run a pod with the container image nginx and expose port 80, let's say that my Kubernetes MCP server, or the MCP server that I created, exposes this function, Kubernetes resource create or update, and accepts a single parameter or argument called resource. And the tool description would be create or update a Kubernetes resource in the current cluster by providing a YAML or JSON representation of the resource. Resource, a JSON or YAML containing a representation of the Kubernetes resource, should include top level fields such as API version, kind, metadata, and spec. So yeah, I'm familiar with Kubernetes. I've implemented a lot of things for Kubernetes, and I think that at least with having the documentation, I would be able to send a YAML file using this function and deploy a pod with the required container image and port exposed. However, maybe if I ask this to someone who has no idea about Kubernetes, probably would have no idea how to start, right? So in this case, this large language model, the Kubernetes expert, is able to fulfill the task successfully. However, the smaller language model doesn't have the knowledge embedded in the model, so it's not able to perform this task using this provided function. Let's say, however, that we have this same prompt, run a pod with the container image nginx and expose port 80. However, now my MCP server exposes this other function, or this tool, pods run, which accepts two arguments or two parameters, the image and the port. And this is the description. Run a Kubernetes pod in the current namespace with the provided container image and optional port. Image, container image to run in the pod. Port, TCP IP port to expose from the pod container. I mean, the prompt is quite straightforward. Run a pod with the container image nginx and expose port 80. Just by understanding English and knowing how to invoke this tool, you would replace image with nginx and port with 80, and you would be able to run or to fulfill the user's prompt, right? So in this case, both the SLM and the LLM are able to perform the tasks successfully. So what's important here? We can use MCP, we can leverage MCP and the MCP servers and the tools to encapsulate the task complexity, to abstract complexity away from the model. So smaller models will actually be able to perform tasks that only larger models with better training would be able to perform instead, right? So this MCP actually allows smaller models to perform as if they were large language models. Why is this important? Because smaller models cost less to run. The price per token of a smaller model is maybe a tenth of the price of running a large language model. In addition, smaller models can actually be run on your device, right? I can run a small model in my Mac M4. So if you have an edge device which is not connected to the internet, it can actually maybe have a model running and leverage AI to perform certain tasks. These tasks be encapsulated by your MCP server. So it's important also here that whenever you implement an MCP server, you shouldn't just be wrapping around a CLI tool or a REST API or anything like that. Like your MCP server should be providing additional functionality, because if you notice, Cursor or maybe GitHub Copilot or any other IDE based assistant is actually able to run commands in your shell. So what's the point of wrapping a CLI tool around an MCP server? There's no tool. There's no point for that. Your MCP server should actually be providing better focused functionality, and functionality that maybe abstracts away complexity. In the Kubernetes MCP server, for example, under the hood, we are actually checking for permissions for the user to execute certain tasks, or creating resources on behalf of the user, or a lot of other functionality that's probably not available when running through a CLI tool. And finally, when implementing your MCP server, you should also consider the tool budget. What's the tool budget? It's the number of tools that your MCP server is actually exposing. And yeah, if you remember in this sequence diagram we saw before when we were talking about the MCP overview, at some point the agent, the assistant, is actually sending the prompt plus the tool context to the LLM. So this is what we see here in the bar chart below, right? So in the LLMs have something that we call the model context window, which is the maximum number of tokens that it can process at once. And whenever we send a request to a LLM, usually a chat completion request will have the system prompt, the MCP tool descriptions, the user prompts, and so on. And then we might have some space, left space, right? Because we didn't fill the context window. But the more tools we have, the more we are going to fill this chart here, this bar. So eventually we might run out of space in this context window. So let's consider that a simple tool can cost between 100 and 500 tokens at least. If we have 20 tools, we can actually easily consume more than 5,000 tokens of that context window just by the tool definitions. So if we are running a small language model, maybe this context window is 4,000 or 8,000 tokens, maybe 16,000 tokens. We're talking that just by having 20 tools, we are consuming around 60 to 100% of this context. So we won't have room left for actually the user prompt, especially if it's a little bit complex, or even for follow-up requests or prompts, right? For larger language models, obviously this is not that of a problem. Maybe you're consuming 4% of the context, say here, but that's not the problem. But however, having too many tools might actually overwhelm your model, and eventually if you have far too many, the model, you will notice that it will actually try to use the tool it has available, even if the prompt is not related to any of those tools. So yeah, you should be actually worried about the number of tools that you are exposing with your MCP server. So these are mostly the takeaways about the tool budget. Probably one of the important things is that we should educate users. Users don't need all the tools all the time. So in your AI assistant, in Cloud Desktop, or in your IDE, GitHub Copilot, or with Cursor even, you can actually select and deselect the tools that you want to send to the LLM for a given prompt. So maybe we should start doing this, right? We should also try to implement the tools wisely to maximize the utility and not overwhelm the model. And this is aligned with what I was saying before. So your tools should maybe extract complexity away, so make it very simple for the models to actually perform tasks. And also they should be tested with the given model. So when I was talking about the tool descriptions and so on, you should actually test these typical user interactions with your tools and fine-tune both the descriptions plus what the tool is actually doing to implement the right amount of tools that can actually leverage or help the LLM accomplish the tasks that your users will typically need. We should also optimize the tool definitions. So as I said before, when you implement the tool descriptions and definitions, try different approaches with the different models and see how this or altering these descriptions affect the way the model is actually using your tools. Also try to make them as short as possible, and but keeping or while keeping the model to still use your tools. You should also know that the target model your MCP server or your users are going to typically use. So if you know that your MCP server will always be used by large models, well, it makes sense that you implement more complex tools. If you know that your MCP server will only be used by smaller models, it has no sense that you expose super complex tools that the smaller model won't have an idea of how to use. And finally, different concepts like the dynamic tool loading. So maybe by using elicitations or several steps, and this also would probably require more control on the client side or on the assistant side. You can be actually able to expose automatically different tools to the LLM. But this is much more complex. So if you're interested, maybe ask me and we can check it out. So yeah, this is the end of the presentation. I hope you've learned that you now know how to better implement your MCP servers. Usually this would be the time in the conference where someone would ask me questions. Fortunately, on YouTube, it's impossible for you to ask me questions live. However, you can send me your questions in the comments and I will try to answer them as soon as possible. You could also send me your feedback there, so I would be very happy to receive your comments. Hope you liked the talk. Thanks for watching.